This is pre-calc lesson 84, number 28. And I'm supposed to find the distance between the point 0, 0 and this line y equals 3x plus 1. So I plotted 0, 0. Now I'm going to plot y equals 3x plus 1. The x-intercept is at 1. Slope is 3. Up 3 over 1. Oh, I had my slap bracelet on a second ago and I took it off. So, well, I'll just pretend I used a ruler on that. So there's the line. And you don't have, it doesn't say you have to graph it, so don't think you have to graph it or anything, but I'm not going to really be able to explain it without showing you the picture. I'm supposed to find the distance between that little teeny point and this line. So the distance between a point and a line has to be perpendicular, where the point is perpendicular to the line. So what we want to do is find, well, we got the slope of this line. We know there's going to be a perpendicularity happening, so we want to get the equation of a line that's perpendicular to this line. So in other words, we're going to have a line that goes like this, y equals, perpendicular you have negative or opposite reciprocals, so it's going to be negative 1/3 x plus b. There's going to be a line. Now this line is going to contain, oh, did you guys all notice what I did wrong? How embarrassing. I'm not going to retape this because it's getting very late and I still have to go to sleep sometime tonight. So I graphed the line wrong. Anyway, this is the distance between. I shouldn't have even drawn the picture. That's the distance, okay? So, right, that's the point. That's the line. I mislabeled my picture. Anyway, so here's the line, and the line perpendicular is going to pass through 0, 0. It's going to go like that. Okay, so I'm going to plug in 0, 0 and find out what b is. Can't I kind of tell what b is? I think b is going to be 0, right? So if I plug in 0, 0, b is 0. So this is going to be y equals negative 1/3 x. So the equation of this perpendicular line is y equals negative 1/3 x. The original line we have is up here. So I can just use equal values, you know, like substitute in negative 1/3 x for y and do a system of equations and solve this and find out a point that's on my original line, and then I can use distance formula. Okay, so I got negative 1/3 x equals 3x plus 1, and then I would like to solve it for x. I could rid myself of the fractions, or I can just deal with them. I think at this point I'm just going to deal with them. There's 1. That's negative 3 1/3, which is the same as 3 times 3 is 9 plus 1 is 10. That's negative 10/3 x equals 1. So I want to solve for x, so multiply by the reciprocal, which is negative 3 over 10. Well, okay, so x is equal to negative 3/10. Okay, so that's the x coordinate of the point where I have a intersection. Okay, so now I need the y-intercept. So I can plug it into either one. Or sorry, I need the y-coordinate, so I can plug it into either one. I got fractions anyway, I'll just plug it into this one right here. So y is going to equal negative 1/3 times x. So that means y equals negative 1/3 times negative 3/10. And that actually turns out okay because I guess we'll have a positive 1/10. So there's y, there's x. I use my distance formula. I'm not super excited about these fractions being in my distance formula, but oh well. Could be worse, right? At least they're tenths. They're okay. So distance formula is that one where we go something take away something squared plus something take away something squared, right? You can do your x2 minus x1, y2 minus y1. That's how I'm going to do mine. So I'll just say -3/10. Remember x1 and y1 were 0, 0. Remember from the original problem. This is 1/10. Okay, and that's going to give me the distance. So if I square that, I'll get 9/100. And if I square that, I should get 1/100. And then I guess I'm going to get 10/100. Well, I guess that would be square root of 1/10. It really is. I didn't think it would be that ugly, but it is the square root of 1/10. So the square root of 1 is 1. The square root of 10 is root 10. And then I can just turn it into, you have to rationalize the denominator. So now I have 1 times root 10 is root 10, and root 10 times root 10 is 10. This is actually, right here, that's the answer. That's the distance between the origin and my line. That's that vertical or perpendicular distance right there. Use the distance formula. So to recap all that and make this video even longer, plotted the point, I plotted the line, I found the opposite reciprocal of the slope of the line and used it to get a line that passes through 0, 0 that's perpendicular to the original line. Then I did a system of equations on that. I just used substitution, plugged that in, found out where the two lines intersected, got the ordered pair of -3/10, 1/10, stuck it in my distance formula, chugged out all those numbers, and that's the distance.